Hi, guys. Let me expand upon that. Upon me. There we go. So, this is the fourth time tonight that I'm going to try to make this video. Seriously, I've gone through the dialogue off the cuff 2 or 3 times. Bit my fingernails a few times. Wanted to tear my hair out, but then I looked at it and said, "That's your best feature." So I didn't tear my hair out, but man, what I'm talking about is dropouts, right? I'm getting dropouts like crazy, or at least I was. I was using a program which shall go unnamed since I don't want to smear anybody. I don't know really why, but this new program is called Ecamm Live, and it's a native app. It's not a browser-based app, so it's got more power. Hopefully, we will have fewer dropouts. All right, so tonight's topic is a connection between Bob Lazar and a current physicist who is really turning heads. His name is Nassim Haramein, and I have a video for both Bob and Nassim to play for you. I just want to give you a little preamble about why we're talking about this. Why are we talking about this? Well, for one reason, Bob Lazar is. I'm a little irritated about the fact that so many people have discredited Bob or tried to. Stanton Friedman was the main UFO researcher who did this, and I felt it was really dumb of him. He basically bought the government's line that no, there is no such person. He never worked here, and Stanton actually believed that, but I don't. I'm the kind of person that I can watch a person being interviewed, and I can tell you within a half hour whether they're bullshitting or not. There's plenty of signs, right? Judge Judy knows how to do it. Well, although she's not really into staring at people, right? She's more into listening to the logic of the story, and if something doesn't make sense, then someone's lying. How did I get on to Judge Judy? I really love that about her, that she just knows how to judge the truth out of a story. Bob Lazar is clearly telling the truth. So let's just put that to bed. There are some people on the internet who should know better, and those people shall go unnamed as well. I'm gonna light up a butt. Can you believe that? These damn things are so expensive now. Okay. You didn't tune in to watch me smoke a cigarette. You tuned in to learn something about Bob Lazar and how alien ships propel themselves through space. But we're not going to get into the complete story on that because that would take too long. I just wanted to give you something simple that I know you'll enjoy. Shouldn't be smoking on camera. That's just rude, isn't it? I mean, I'm not here to be like academic. I'm here to be entertaining if I can. I'm learning how to entertain myself. I'm looking at the screen at myself all the time, and I'm very entertaining. No, um, actually, it's quite painful, but I'm getting over that. Focus. All right. I also have this. There's no question in my mind I'll be deleting this video because, well, I started out a clean man at 8 o'clock this evening, but it is now 12 o'clock. And I've been battling tech issues all night, so I'm going to have a puff too. Do you want me to play some music? Let me play some music first. This is from my band in 1986. And I'm not playing this because I just want to promote my band, but I'm playing it because there is no copyright issue because we wrote the damn thing. This is called Morning in the Meadow. Let me see if I can get it to come on for you. First, I have to share the current application, which, oh, this is really nice software. Very, very nice. Okay. Just go ahead and play yourself. How's that? Let me see. I don't hear anything yet. Wow, that was the wrong song. That's better. Okay, I only did that so I could do this. By the way, that's me right there. Okay, enough of this. All right, enough of that. Stop sharing. Okay. Is my heart even really in this anymore? I've been thinking about Bob Lazar a lot because he has been bashed, and I need to turn this up a little bit for myself, not for you. Check. Okay. Yeah. Am I the only one that happens to? I hope not. Gosh. You wanna learn a little bit about alien propulsion? Yeah? Okay. I think it's fascinating. I really do. So, what's fascinating? Okay, what's exciting here is that there's a guy named Nassim Haramein, and he is a new physicist, new to me, and he's an up and comer, and he is working outside the mainstream. I mean, he's a full-fledged physicist, but he's like he's working on things that mainstream everything is fucked up. So he's not mainstream, but he is certainly just as smart as anyone in the mainstream. And I would wager that he's got even more smarts. The guy seems to be a prodigy, but he's also a whole person type of person. In other words, he feels like everything is connected. Physics, your soul, your consciousness. Although he doesn't, get into esoteric subjects, that he sticks with physics, which is great. But the physics that he is exposing or theorizing is syncing up with other people like, believe it or not, David Wilcock. I hate to bring up the name because I know that he is such a grifter, but he is a big researcher, and a lot of his research, not just from Law of One, but other areas, is pretty interesting to me. I mean, it's interesting how all of this is coming together. I haven't sprung the exciting part yet, but maybe I should just put that out there now because I think I can. So what has happened is that how much prelude do I need to give you for this? Actually, I do need to give you a lot of prelude. Okay, so let's put on our physics caps and remember basic atoms. Okay, so in an atom, we have a nucleus. And the nucleus consists of protons clumped together and maybe some neutrons. But protons are charged positively. And therefore, since they have like charges, each proton has the same positive charge, same polarity of the charge, they repel like a magnet, like a north and north would repel if you pushed them together. And so how in the heck are these, physicists asked, how in the heck are these protons sticking together? What is holding them together or pulling them together? Their first thought was, is it some sort of gravity? I'm imagining that was their first thought. But it couldn't have been in their eyes. So they had no idea what it was, but it really wasn't important. What was important was that they could measure, or not measure, but they could attribute, just say, there is a force called, we're just going to call it the strong force because it seems to be really strong. And it's pulling strong in the sense that it's overcoming the repulsive force. And so whatever this force is, it's strong and it's holding the nucleus together. And that's all they really knew. Okay, so then Bob picks up the picture in 1989. He picks up the story and tells us what he's learned from reverse engineering alien propulsion craft at Area 51S4. And I'm going to play an excerpt from Bob, and hopefully this will set up my segue over to Nassim. But Bob is going to explain how this element 115, maybe I should give you a precursor so that it, when you hear Bob talk about it, you'll get it twice, right? It might help. Let me take a drink. Okay. Like I said, there's no doubt I'll be deleting this video, so. Yeah, I got my headphones on too, don't I? I don't think I need my headphones on. Okay. All right, so let's picture an atom. And the protons, because of the force we were just talking about, the strong force, the nucleus of the atom are a bunch of protons and neutrons clumped together tightly. And then you've got the electron going around, right? Now, the strong force, they don't know what it is, but it has to be strong to overcome the repulsive force of the positively charged protons. So physics went on and just said, we don't know what it is. We'll call it the strong force. Then Bob comes along and after having studied the alien propulsion craft, he came out and told us what he had learned about the alien propulsion craft. Now, mind you, he didn't learn everything because he was so impressed with this technology that, I mean, you could see it in his eyes in a lot of his videos. He said, I don't even think we will have it reverse engineered in 20, 30 years. I just don't think, So in other words, he really doubted whether anybody could figure out some of the finer details. But they did get a lot of understanding about element 115, which they had in their possession. This is I'm getting ahead of myself. Okay, so Bob is going to explain that there is an element called, back up even one more step. When we're talking about the proton, right, and the strong force which keeps the nucleus intact, that Bob is going to tell you that strong force is gravity. He thinks it might be a different kind of gravity because he didn't know Nassim's work, which we'll get to. But he did say that it was gravity, and that was the first time anyone had ever said that. So he has really been vindicated now by Nassim's theory, at least. So, vindicated in a sense. And Bob is going to say that, we don't have any idea how to generate gravity, but we don't have to, because element 115 provides a little bit of gravity wave that we can then amplify, just like an electromagnetic wave, like a radio wave. We can amplify these things because waves can be amplified. I don't know if Bob knows how they amplify gravity, and I don't think anybody knows yet, but he knew that it was being amplified. That much he could tell. Maybe he does know. I'm just guessing because I never heard him explain how do you amplify gravity waves as opposed to magnetic waves. I don't know. But so what he's going to describe is that in element 115, which is a very heavy element that does not exist native to this planet, but science does admit that element 115 is theoretically stable, and they have created it in a collider, but of course it what's the word? Decomposes immediately. It's very unstable in the collider environment. But they admit that theoretically it could be a stable configuration. Just haven't found it on this planet. But they had it at Area 51, and it came from somewhere else. It came with the technology that they have recovered there. They had 9 different saucers there at S4. Bob started explaining that element 115 has it being a very heavy element. It has a very big nucleus, right? That's what gives it the weight. And that means that there's a lot of protons in there. And it just so happens that in most atoms, even some heavy ones, heavier than element 115, the gravity that is the strong force is really only, it does not extrude beyond the surface of the nucleus. So it's not accessible in most atoms. But for some reason, in element 115, I don't know if it's the size of the nucleus, the configuration of the nucleus, for some reason there is an abundance of gravity such that it actually extrudes beyond the nucleus by a small amount. And that small surface area of the nucleus where the gravity wave is can then be tapped into and amplified. and that's what they're doing. So that's the basics of how they can grab some gravity wave that they're not generating, but element 115 is generating it, and they're amplifying it. And they're amplifying it with electricity, just simple, electricity. But a lot of it. And where does that come from? Well, that also comes from element 115. As I understand it, what he described was that this is a very, I mean, Bob kept saying how slick the physics was, because he just thought, oh my God, that they're using this element for two completely different things, and it's the same element, and they're just really, that Bob just kept thinking, whoever these beings are, they're very, very smart. He was blown away by it. Okay, but what we're talking about is that element 115 has this other unique characteristic, that when you shoot a stream of protons at a chunk of element 115, it will output an antiproton. And then what they do is, I guess, funnel it into a reaction chamber that transduces. Then they let it collide with a normal proton. So you got a proton and an antiproton, and that's antimatter, right? So when they meet, they completely transform all of their matter into energy. It's complete transformation. So it's the biggest production of energy that you can get, and that's a lot of energy. So they have some kind of containment area for that to happen, and what they do is they just, just like our nuclear power plants, or all we're doing is boiling water with the hot rods, right? And then above that, it's like a steam turbine is what we're turning with the nuclear. Well, the same goes here. They're just transducing this extremely powerful explosion, maybe through piezoelectric means. I don't know what, but they're transducing it into electricity. So you're just talking about a very, very efficient and powerful electric generator. And that's what they use to amplify the gravity waves. And then how they actually move through space is they put a gravity wave amplifier, one on each side of the ship. Okay, and the ship, it's on the bottom of the ship is these three gravity wave amplifiers in a triangle position. They just use the outer two mostly, and what they do is that they actually go like this, like they're vertical, a vertical flying saucer, imagine, and then the two emitters that are on the opposite sides of the disk, they focus their gravity wave on some point in the future, so that the two sides of the ship, the beams, converge at some point in the future. I mean, in the distance. I don't know what the distance is. It could be a long ways off. And then they just crank up that generator, so the gravity waves are just really strong. And what that does is it brings that point in space that is distant, where those two lines converge to a point. It brings that point in space-time all the way here. It bends space-time, because that's what gravity does. We know that. And then they can travel through a small distance between that point in space. That distant point was brought very near because of the powerful gravity wave amplifying. And so really now you're very much closer to point B, your destination, than you were before. So you just travel that small gap between where you are now and where point B is. And to an outside observer, it looks like you've gone faster than time, but you haven't. Because locally, space-time has been completely warped. Like Biden's brain. But so that's how it works in a nutshell. And I would like to add one more thing because it's kind of interesting. I don't know if you've ever seen photos of flying saucers that seem to be wobbling a little bit. Like, I can't quite do it, but yeah. Kind of, well, actually, it's been described as kind of like a leaf, the way a leaf falls down. Yeah, like that. And that, for all the world, looked like to us, originally, to us humans that were observing these many years ago, like a hubcap on a string. I mean, it really looked like the string would explain that hovering movement. It's just going, well, almost would explain it. It doesn't quite explain the pendulum effect, but it does kind of explain the back and forth, right? So, gosh, that was an unfortunate coincidence because it turns out that these little flying saucers that have the three emitters, they're not very stable, like when they're just trying to hover. And so they do have this because they're just using these two and maybe the third one too. I don't know, but they're pointing them down at the ground now instead of pointing them out in space. And when they're pointing them at the ground, it doesn't really guarantee that they're perfectly level. So that's how you explain that movement. Now the big ones don't suffer from that, but the little sports models do. That's what Bob called the one that he was using. So without any further ado, let's go to listen to Bob talk a little bit about this.
The next question is, how do you generate a gravitational field? Up until this point in time, I've used the term generate to describe the capability of producing a gravitational field, but since I'm not aware of any way of creating a gravitational field from nothing, a more accurate term might be to access and amplify a gravitational field. And this is what I mean when I use the term generate. To understand how gravity is generated or accessed and amplified, you must first know what gravity is. There are two main theories: the wave theory, which states that gravity is a wave, and the currently accepted theory of gravitons, which are alleged subatomic particles that perform as gravity, which is total nonsense. Well, gravity is a wave.
At that time, Bob was making a call here that no one else could make because no one else knew what gravity was. Bob is making the call that gravity is a wave.
And there are two specific...
not a particle.
...different types of gravity. Gravity A and gravity B. Gravity A works on a smaller micro scale, while gravity B works on a larger macro scale. We are familiar with gravity B. It is the big gravity wave that holds the Earth as well as the rest of the planets in orbit around the Sun and holds the Moon as well as man-made satellites in orbit around the Earth. We are not familiar with gravity A. It is the small gravity wave which is the major contributory force that holds together the mass that makes up all protons and neutrons. Gravity...
So here Bob is saying that gravity is holding those protons together. But he's calling it gravity A and differentiating it from normal gravity, which is gravity B. But I think that he may not have to do that. After we hear from Nassim, it's all the same gravity. It's just gravity. Now you may ask yourself, where in the world is a proton going to have enough gravity inside of it? But that's the beauty of what's happening with Nassim. So we'll get to that.
A is what is currently being labeled as the strong nuclear force in mainstream physics, and gravity A is the wave that you need to access and amplify to enable you to cause space-time distortion for interstellar travel. To keep them straight, just remember that gravity A works on an atomic scale, and gravity B is the big gravity wave that works on...
That's why he called it gravity A, because It's short for atom, atomic. And B, what did he put for B?
On a stellar or planetary level. However, don't mistake the size of these waves
Can't
for their
read it.
strength, because gravity A is a much stronger force than gravity B. You can momentarily break.
Okay, that's important. Now, yeah, let him talk about gravity, our normal gravity, how weak it is.
The gravity B field of the Earth simply by jumping in the air.
You can overcome it simply by jumping in the air.
So this is not an intense gravitational field. Locating gravity A is no problem because it is found in the nucleus of every atom of all matter here on Earth and all matter anywhere else in our universe. However, accessing gravity A with the naturally occurring elements found on Earth is a big problem. Actually, I'm not aware of any way of accessing the gravity A wave using any Earth elements, whether naturally occurring or synthesized, and here's why. We've already learned that gravity A is the major force that holds together the mass that makes up protons and neutrons. This means the gravity A wave we are trying to access is virtually inaccessible as it is located within matter, or at least within the matter that we have here on Earth. However, the Earth is not representative of all matter within our universe. The residual matter which remains after the creation of a solar system is totally dependent on the contributing factors which were present during the creation of the solar system. This is true whether you believe that the origin of the universe was an evolutionary event or that a supreme being caused this event to happen. The two main factors which determine what residual matter remains after the creation of a solar system are the amount of electromagnetic energy and the amount of mass present during the solar system's creation. Our solar system has one star, which is our sun, but the majority of solar experiments the lab for heavy ion research to the atom. These heavier...
Here we go. There's another little bit here I want you to hear.
History, there has been no physical evidence to prove this, but now that proof is here. The most important attribute of these heavier stable elements is that the gravity A wave is so abundant that it actually extends past the perimeter of the atom. These heavier stable elements literally have their own gravity A field around them, in addition to the gravity B field that is native to all elements.
Okay, so he's saying in the heavier elements, I guess he's including more than one, but, well, 115 is the only one he has seen this in. And we don't know of it, you know, the scientists don't admit to having element 115 at all, so, of course they wouldn't if they were in Black Ops. I think that's all we need to do, here with Bob, because we could go on forever with Bob, and the main thing we want to get across is that in element 115 the gravity, there's an abundance of it. There's like a wave around the nucleus that is extruding around the nucleus, and I guess that means that even, you know, if you take a physical chunk of this stuff, which contains trillions and trillions of these atoms, that the whole thing has a field around it that can be amplified, and so that's how they do it. But the question that Bob was never able to answer was, where does this gravity, how, you know, he said that it's much stronger than the Earth's gravity. So it must be a different kind of gravity, but it is gravity. And now here comes Nassim to talk about how that could be possible, because Nassim is saying that within every proton is a mini black hole. And I'll play the video in a second, but first of all, I didn't even know there, well, I mean, I guess I heard something about mini black holes, but I thought it was just nothing. But apparently, oh no, it's very, very theoretical, very, very plausible. And so he's saying at the center of every proton is a mini black hole. Well, that's the source of the gravity. That's the strong force then. It's quite amazing, quite interesting.
In the Schwarzschild proton paper, I start to explore the relationship of the...
it just kind of starts mid-sentence for some reason.
Schwarzschild proton paper, I start to explore the relationship of the proton to the scale. And the reason is that if you look at the scale in 2008, the atom falls on that line, right? And the atom and all the other data that's on that line are mini black holes, or large black holes, right? Mini black holes being the Planck scale, and then larger black holes like the center of galaxies and so on, or stellar black holes and all this. So I started to think of the nuclei of an atom as a mini black hole, because I could see that like there was this infinite scaling going on since I was small, since I was a kid, and clearly if there was infinite division of the small stuff, then eventually that small stuff would act like a black hole itself, right? Because it had infinity within it. And so, you know, the Schwarzschild proton is a fancy way of saying the black hole proton. And so I wrote this paper because when I calculated what would happen if we made a proton a little black hole, I got the right answer for very important questions in physics, which had to do with the strong force. That is, two mini black hole protons interacting with each other would produce a gravitational force exactly of the same strength of the strong force that we observe. So,
did you hear that? What he's saying is that with his physics, I don't know how to interpret, you know, because I'm not a physicist, but he said, what did he say? If I turned a proton, if I thought of what did he say? Let's hear it, because this is a very key aspect here, key part.
A gravitational force exactly of the same strength of the proton interacting with each other would produce a I got the right answer for very proton is a fancy way of saying the black hole proton. And so I wrote this paper because when I calculated what would happen if we made a proton a little black hole,
what would happen if we made a proton into a black hole? Oh, by collapsing it somehow. Yeah, I think that's what he means. Because, you know, you make a sun into a black hole by gravitational collapse. So apparently the numbers work out that if you turn a proton into a black hole, a mini black hole, and then look at the amount of force that attractive force that creates for another mini black hole proton, it equals exactly the strong force. That's an amazing correlation.
I got the right answer for very important questions in physics, which had to do with the strong force. That is, two mini black hole protons interacting with each other would produce a gravitational force exactly of the same strength of the strong force that we observe. So for me, it was like, okay, this cannot be a coincidence, right? That cannot be a coincidence. And I had lots of tomatoes thrown at me for that paper because, you know, and in the paper I show it and I mention it, is that the proton with a black hole mass falls nicely for all of the masses in the universe, but the standard proton mass that we measure is completely off the scale. A solution, right? To understand the.
That was good. I don't even understand most of it, but you know, I don't know if you got what I got from that, but I think the guy's on to something. I mean, I've been listening to a lot of his talks, and I'm no physicist, but I can tell he is. And I can tell enough that he is probably going to be the next Einstein. Telling you. Telling you. Okay, so what have we learned before I sign off here? And I was going to play some music. Did I do that in the beginning? I don't even know. So, like I said, this is my 4th time doing this broadcast tonight. So I just said, fuck it. I'm going to drink. I'm going to smoke. Not that it, by the way, I don't drink much. This is like the first beer I've had in a day. No, seriously. I drink a beer every once in a while. Tonight I wanted one because I went through so much crap with software issues. But I really recommend this Ecamm Live to all you people who want to start your own webcam. YouTube channel. It's really good stuff. Ecamm Live. So what have we learned? We've learned that Bob Lazar was right back then. He was right. But of course he was right because he was looking at some real stuff. So what it means really is that he was telling the truth. That's what it really means. So people today, I would say, I don't know, the field is mixed. I think there's a lot of UFO researchers who really are lazy and really cannot judge truth out of the mouth of a witness. I think those people still think that Bob Lazar might be lying because he doesn't have like some of the credentials. He can't prove that where he went to college because they pulled his credentials. You know, the CIA can do that shit. It seems a little far-fetched, but and some people are saying, well, maybe he did lie about his credentials. I don't know. I don't think so. Bob had no reason to lie about anything. He had the job. So I guess this has been a defense of Bob Lazar. So I hope you guys feel the same way, especially after seeing this. And I hope you learned a little bit of something about physics. That's like me. I know a little something. That's about it. But I'm sure captivated by it. I think we're going to find that physics is what ties everything together and makes it real. So paranormal stuff, telepathy, all kinds of things are going to come to light soon because they've already come to light in the alien world, you know. So that's all. Good luck and good night. See you next time. Okay, how do I stop this thing? Oh, finish. End broadcast.